All right, hopefully you can see this problem here. If not, maybe you have it in front of you. But it's basically a rate of change problem with a Pythagorean theorem formula. So you have your right triangle and they give you some parts of the triangle. So they call this y and that's equal to 15. This is x. And I don't think they tell you what x is, but you could figure out x because they give you z, which is 25. So x squared plus y squared equals z squared, and you have z and y, 15 and 25. So if you square those, you get 225 and 625. That's 15 squared and 25 squared. So you just subtract the 225 to the other side, and you get 400, and then you take the square root of that, which is 20. So this x is 20. That's where the 20 came from. So there's your Pythagorean theorem. There's your distances. And then the story with these distances is that they're shrinking. This is getting pulled that way. The boat is getting pulled that way, and it tells you what the rate of change is for that. That's 30 feet per second. So since we're going to do a derivative here, that's going to become your dz over dt, your change over time in the z direction, and that's 30. So when we start doing the derivatives, we're going to end up substituting in 30 for the dz over dt. All right, and then what we want to know is what is the dx over dt. That's the problem here. That's what we're trying to figure out. What is this rate of change? As the boat is being pulled this way, this distance is also shrinking. It's getting smaller, and that's the rate of change that we're trying to find out, the dx over dt. So we need a formula that we could take the derivative of, which is going to be the Pythagorean theorem. So that's going to be your x squared plus your y squared equals your z squared. And then you could take the derivative of that, but it looks like they substituted in the y first, so let's just do that. So they substituted in the 15 for y. Then they took the derivative of this, and when you take the derivative of a constant, it's just 0. So that 15 squared goes away. That's kind of immaterial. The only reason we needed that 15 was to figure out that this was 20. Now we're kind of done with that 15. It doesn't really factor into the derivative at all because it cancels out to 0. So you take the derivative of this, x squared is 2x, and then you still have the dx over dt, and 2z dz over dt. So that kind of looks like this right here. So that's what that is, was taking the derivative of this equation. All right, now we start substituting in numbers here. X was 20, so we got 2 times 20. That's 40, so we have 40 dx over dt. Hopefully that's showing up on the camera. It does not appear, so let me move that. All right, so we're going to substitute into our equation that we just took the derivative of. X is 20, so 2 times 20 is 40. Dx over dt, we don't know. That's what we're trying to figure out. Z was 25, so 2 times z is 50. And it was 2z times dz over dt, and dz over dt was that 30. That's the rate of change being pulled that way. So that's times the 30. So that's what this is right here. And now we want to solve for dx over dt. So we just multiply those two numbers together to get 1500, and then divide by 40, and the dx over dt will be all by itself. It'll be 1500 over 40, and that reduces to your 75 over 2. So that's where that came from. The only problem I can see here, which I think is a mistake, is this is the d, they're calling this dz over dt instead of dx over dt. So maybe I'm reading this wrong, and maybe the 30 feet per second that they give you is actually this distance, and you're trying to solve for the dz over dt. So that could be. This is a little bit confusing the way it's written, but regardless, both of these distances are shrinking, and one of them's at 30 feet per second, and then you're solving for the other one, which ends up being 37.5 feet per second. So it's possible that this was actually the 30 and this is the 37. I read it the opposite way. But regardless, the math stays the same. That's how you do the problem. You use the Pythagorean theorem, you take the derivative of it, and then you just substitute in your numbers that you got over here. Most of them they gave you. One of them you had to figure out for yourself, the 20.